Presentation is on the new Rotax engine, the 916IS. And with us tonight is Nino Tavio. He's a Rotax Flying Safety Club instructor. He's been trained by the Rotax factory as a technician. He is the owner of JT Stealth, which is an aviation consulting organization that works on OEM installations. He also works with the Transportation Safety Institute on accident investigations for Rotax engines, and he's an EA member. Nino, welcome, and we appreciate you coming on and talking about the new Rotax engine.
Hello, Charlie. Can you hear me just fine?
Yep, 5x5.
Excellent. Thank you very much for that great introduction. I really appreciate it. I also want to thank EAA for this space and, of course, all of the work that they do in aviation. Special thanks to all the volunteers that really make AirVenture possible. In just a few weeks, we will all be celebrating there. I personally will be celebrating my half-century mark at the first day of the show. So a good celebration for everyone. Of course, I want to thank you for taking the time and spending it with me tonight for some information about the new engine that Rotax is putting out. Of course, another model of the 9 series that started over 30 years ago. And again, I can say that this is the highest horsepower Rotax aircraft engine in production to date. And of course, we're talking about the 916IS. Now, this engine was certified in Europe under EASA rules. There were some prototypes that were provided to OEMs at the end of last year and the beginning of 2023. So some people already have a little bit of experience. Most people are very familiar with the Rotax 915 engine. This engine is found in many aircrafts in the market. Some certified aircrafts, some that are primary category, mostly really experimentals. Some examples are Kit Fox, which has probably the most experience with the 915 engines. They will apparently have quite a few 916s at their booth this year, so that'll be nice. Rance, of course, has quite a few 915s available. Skoda introduced their aircraft with the 915. Autogyro uses the 915. Just Aircraft, Silverlight with the Ranger R1, Bristol, and many others. And we know the 915 has 141 horsepower at 5,800 RPM with an installed weight of about 210 pounds. It is capable of maintaining maximum power to about 15,000 feet, which is quite high. Customers still requested more horsepower without any weight increase. Some people thought it could not be possible. So in reality, they were right. After many hours of testing, the 915 revealed some things to Rotax. The engine cannot make more power reliably. So many changes were needed. So the 916 is not just a boosted 915IS. So Rotax wanted to increase the power. They really wanted to increase the power with less fuel. And many people said that more power could not be achieved from this engine. So they nicknamed the project the Impossible Engine. Now, Rotax only releases aircraft engines models after they have been performed very extensive test bench hours and gone through EASA certification in Europe. They also make sure to meet the latest ASTM standards. And when they are released in both ASTM and certified under EASA CS-E. Now, the certified engines and its parts come with a Form 1 and accepted by authorities globally. What is the engine? Well, it's a 4-cylinder, 4-stroke, liquid air-cooled engine with a post cylinder. So it's basically the same platform. It's a dry sump lubrication, same with an external tank. The one thing that you will notice here between the 915 and the 916 is, of course, they have a muffler and an after muffler that wasn't there on the 915. And now the 916 is being released with 2,000-hour TBO. So the full takeoff is maintained still to 15,000 feet. It's still a best power to weight ratio in the market. And it's an extension of the 912, 914 engine family that has proven reliability with more than 15 million flight hours so far, and more added daily. Now, Rotax is adding 5,000 engines per year to the field around the world, and this makes them the largest producer of piston aircraft engines. The engine's released at 160 horsepower at 5,800 RPM, with a maximum continuous of 137 horsepower at 5,500 RPM. Now, the engines right now are being delivered in version 3 for constant speed propellers, but they're also available in version 2 for fixed pitch props. Now, realistically, this is not recommended for fixed pitch propellers if you want to be able to use all of the power out of the engine. Mainly, it's going to be for experimental aircrafts. There will be some certified aircrafts and some PC aircrafts that will use it. But I don't see very many light sports aircrafts legally using this engine due to the weight to power ratio. This could possibly change with the new rules in the near future, but that's in the near future. Now, the engine's a 12-volt engine, and the 24 volts capability is for aircraft charging. Now, the starter will reflect the voltage available, and so will the battery, of course. The current status of the engine is that it has almost 1,000 flight hours, with more added daily. There are over 10,000 hours of test benches that are been basically many engines, not just one engine, many engines have been tested over that time. There are over 30 installations of aircrafts globally right now. The first actual customer installation in the United States was in January of this year. The first customer flight of the 916 was Cub Crafters with their Carbon Cub UL. They actually flew it to Sun and Fun this year to make the announcement. And retail delivery of the engine is on the second quarter of 2023. There are quite a few OEMs already receiving this engine, and there are some end users that are receiving this engine. By now, this information has changed because more engines are being delivered and more are being produced, and of course, more are on the way. So if you want an engine, you can call any one of the providers at the service centers. So although some of the parts are from the 915, lots of parts have been changed, and in reality, some are new. I would also say that it's almost a new engine. So right now, I'm going to go over what those changes really are. All of these areas have been improved. In reality, there are over 20 major differences between the 915 and the 916. Keep in mind that this engine is the latest evolution of the 9 Series engine that really started at 80 horsepower back in 1980s, mid 80s. So the crankcase was improved and it has new machining process. The crankshaft has been upgraded to be able to withstand the different loads, the higher loads. The camshaft has a new profile to essentially allow a little bit more air into the combustion. Ignition coils have changed, they are new. Of course, there's a new ECU calibration in order to make all of this work. There are new internals to the gearbox in order to make it last. There is a larger intercooler that's actually required with the engine. As I said, there's a new muffler. And in reality, they actually had to develop a new oil for the engine because the Aeroshell Sport Plus 4 wasn't enough. Because Rotax designates their horsepower by color on the valve covers, of course, the first thing you're going to notice is that the color has changed. The valve covers are going to be like a very light gray, just like the injector covers, which is just for aesthetics. I call it subtle gray because it's almost like a little whitish, but it's definitely a grayish color. So the first thing you're going to see is the color change. Now, there are several ways that you can make more power with main components on an engine. You can increase the bore size, which it wasn't done on this engine. You can increase the stroke, which again, that was not done here. You can just increase the boost pressure, And we'll talk about a little bit more of that. But either way, somehow you have to get more air volume into the combustion. So the air volume must increase. And they made a new cam profile for the 916. So that's part of it. The rocker arms also have new machining process, and they have improved contour for longevity. The rest of the components are basically the same as the 915 IS, and in reality, some are the same as the carb engines, because Rotax tries to use as many of the same parts throughout the aircraft engine range as possible. In these documents, Rotax introduced a new instruction document called SI Pack. In the SI Pack, it stands for Service Instructions, Parts, and Accessories. And what this is, it lets you know the components that essentially are going with the engine that weren't necessarily certified with the engine. And this document not only tells you what the components are, but also how to work with them and how to do things. And the reason I tell you that is because I'm going to talk about this next subject, which are the intercoolers. Of course, the 915 and the 916 are turbocharged engines. So was the 914, but the 914 was such low boost that it really didn't need an intercooler. The 915, the boost was increased, and therefore they had to have an intercooler in order for it to bring the temperature down. And so does the 916. Now, this intercooler that I'm showing here is what the standard intercooler is for the 915 and the optional one for the 915. When you look at their sizes, you see that the size is 9.5 inches by 7 inches by 2 inches thick. It's really not very big. And we know that the turbo pressure increases inlet temperature. And the higher the pressure goes, then the higher the temperature goes too. The inlet temperature of the engine needs to be as low as possible and definitely under the limits for best performance. Of course, the intercooler is really determined by the aircraft manufacturer in the end. But in addition to the new camshaft profile, Rotax also increased the working boost pressure to achieve more power out of the engine. And because the 916 has higher boost pressures, the actual outlet temperature of the turbo is going to increase. And in order to bring down the inlet temperature at the airbox, the size of the intercooler has to be larger. And of course, a proper airflow needs to go through it in order to bring that temperature down. You can see there are almost, when you put them side by side, there are almost 4 inches wider on the 916, 1 inch taller with the same thickness than the standard ones on the 915. There are 2 options available for the large intercooler, the same as the smaller intercoolers, inlet and outlet on the same side. You can have inlet and outlet on opposite sides. Now, the large intercooler can also be used for the 915, and if possible, I would recommend it, because as we know, the lower the inlet temperature, the better the performance you're going to get. Now, because now the camshaft that has changed, Rotax has also wanted to increase the turbo boost pressure, which they did to get more air into the cylinders. Of course, since there's more pressure in the airbox now, the airbox connections to the intake manifold had to change in order to be able to hold that pressure in place. So this required a new connection between the airbox and the intake manifold, because we want to be able to hold that boost pressure. When it comes to pressure pipes between the turbo, the intercooler, and the intercooler and the engine, we always recommend using aluminum tubes with short silicone connections between them. And this would allows you to have the best control of the boost going into the engine. This is a very important topic, the fuel supply to the engine. Now that all this massive amount of air is being forced into the engine, because remember, this is a pressurized, this is a boosted engine. It's not a normalized engine. So all this air has to go in there. If the correct amount of fuel must be injected into the engine, or the engine will not last. It will lean out and a book by Smokey Yunick, which is a very legacy engine builder for NASCAR, says that an engine can completely destroy itself within 2 RPMs with the wrong mixture. So you can just imagine 2 RPMs is nothing when you're cruising at about 5,000 per minute. So the fuel, its pressure must be ideal. And the 912IS fuel pumps will not work with the 916. So new fuel pumps were provided by a reputable fuel pump manufacturer, and they are specially made for Rotax. They are not the same as cars, as automotive, because one of the key things for these fuel pumps is that the fuel pump body has to be isolated from the electrical connections, and that doesn't happen out in the automotive field. And the 915 pumps essentially are the same as the 912IS, so they are not really recommended for the 916. In reality, Rotax is starting to do some testing of these pumps on the 915 because there is a possibility that these pumps will be fitted to the 915 engines. Just a topic on the 915 real quick for anyone listening that owns a 915 perhaps. I recommend running the engine after startup. You always start the engine on one pump, but after the engine starts, make sure you turn on the auxiliary pump and you don't turn it off until you land again and shut off the engine. Especially in the United States with automotive fuel, we recommend using both fuel pumps all the time. What you see here in this picture is this is going to be the delivery spec for the fuel pumps in the future. You can see on the left, the fuel pump is individual. That is just if you need to replace a pump in the future, you only replace the pump without needing to replace all the extra parts. On the right, you're going to see that this is a installation kit that essentially has clamps to hold the pump in place. It has the electrical connections to make it happen. It has the fittings to turn it into AN-6, and it also comes with the check valve, -6 AN check valves for the system. Of course, you would get 2 fuel pumps and 2 installation kits, but this allows different options for OEMs to install it in different locations. There won't be any steel brackets or assemblies so far planned for the fuel pumps on the 916. So now that we have all this air, proper injection of fuel, they really need to ignite it at the precise time to get the best combustion. One thing perhaps a lot of people don't realize is that the higher the combustion pressure is in the cylinder, the stronger the spark that's required in order to ignite it. And because the combustion pressure in the 916 is much higher than the 915, the spark needs to be much stronger. And therefore, a new coil has been introduced with new electrical connections at the harnesses, and these coils allow for better control of the combustion. There's a very good possibility that these coils will be retrofitted to the 915 in the future. So when the 915 was introduced, a larger turbo from a new supplier was introduced with it, much larger than on the 914, and it had an integrated pneumatic wastegate control that it's electronically controlled by the ECU, the engine control unit. Now, the turbo for the injected engines are now being built at Rotax. They are doing all of the process of assembly and balancing, and essentially they brought it in-house to try and maintain the higher quality. Now, the muffler also plays a big part of the calibration of the engine mapping. Now that all the power is being produced by the engine, it must be released properly. So a new muffler design with lower back pressure was introduced, and the additional power makes louder noises, of course, and a new after muffler was introduced. This allows stricter noise restrictions to be met in Europe. And of course, because the European noise restrictions are so much stricter, Rotax needed to address that somehow. And this is when a new after muffler was added. As you can see, the after muffler can be rotated if it's going to be a tractor or a pusher application. Now, the noise restrictions are really for Europe, and some manufacturers don't plan, would like to have their aircraft, if in European operation, they will likely remove them to go somewhere else. Other people might even relocate them, and that's okay. The one thing you need to realize is that you don't gain any power by removing it. So you're better off just keeping it quiet and being a good neighbor so that people don't complain about other people flying around. So on the 916, in reality, almost all electrical components and sensors are the same as the 915. Of course, with the exception of the electronic control unit, that's just for the 916, the new coils that they have introduced, which will likely go to the 915, and the fuel pumps, which are likely going to be retrofitted. But now that all this extra air is going into the engine, more pressure is going in, we have more fuel going in, we have a bigger spark, we have more open exhaust. The only way to make all of these components work together is to properly ensure that this power is available when the pilot demands it, is through many hours of calibration in many different conditions. And this is why Rotax spends so many hours before actually releasing the engine, because it allows them time to make sure that everything works. Now, all the calibration is performed in with MOGAS, 91 octane or better, with less than 10% ethanol. Why do they do that? Is because it allows them to use better equipment to calibrate the engines. Because if they were to use leaded gas, they wouldn't be able to read the proper mixture. They could only do it by temperature. And with a lambda sensor, they can actually do the mixture of the engine much better. And therefore, that's why they calibrate the engine with MOGAS. So now we have really an extra 20 horsepower that now it's making 160 horsepower on this engine. They have to be properly harnessed because remember, the engine has to last 2,000 hour TBO now. The only way to absorb all of that, the pistons have to be reinforced there. So they have new reinforcement for strength and durability for higher loads, of course, because now the boost pressure is higher. They also have a new coating around the skirts of the pistons. They also have a machining process because they're accepting a new ring package, and they have a different compression ratio. So the ring package is had to be machined into the pistons differently than the previous, and new main bearings were also designed with additional layer of protection. The crankshaft had new machining to accept these bearings. So all of these components had to change in order for them to not only make the extra power, but also be able to make the 2,000 hour TBO. Again, you can see in the crankcase has been reinforced around the main webs for added strength, right around where all the power pulses are going to be. Of course, it is also machined to accept these new bearings. There's a needle bearing on the crankcase for the prop shaft that has a new design, so essentially the crankcase had to be machined for that too. And they introduced new hardware for the crankcase in order to withstand all of the high pressures that are being introduced into the engine. So they wanted to try, with all of the testing, all of their new design, make sure that the engine was able to last as long as possible. And they did a really good job to make that happen. Now, of course, the engine is making more power. And with this new added power comes added heat. that is being generated inside the combustion chamber. And this heat really needs to be dissipated as quickly as possible. So there's a pretty good chance that you have to do the test, which is called the hottest day test condition, which you have to take measurements of the cylinder wall uh, on a hot climb out, the hottest day possible, on a 5-minute full climb, and make sure that the cylinder walls are staying within limits, ideally a little bit below limits. But if not, then we're going to need to install one of these air guides that allows the air, the proper amount of air, to be moving through the cylinders to maintain them at the proper temperature in order for the engine to not overheat. So this is a test that now, it used to be suggested before, and very few installations were actually requiring them, but there's a pretty good possibility that more installations will really need to use the air baffle in the future, especially with the higher horsepower engines. The oil system in the engine hasn't really changed very much from the 915. The oil tank still has the same layout. They have the -10 outlet from the tank to the oil cooler, and from the oil cooler to the engine. And they also have the same -8 returns back to the tank, which you have to use both of them on the generator side. The oil pump is the same. The pressure pump is the same as the 912 IS, and they did still use the same suction pump from the turbo as the 915. So one of the other things that was introduced with the 915 that is now being used on the 912 IS is the silicone water hoses, which actually is very beneficial, which makes them unconditioned, and no more do they need a 5-year replacement. So the maintenance cost tends to be a little bit lower with this. But keep in mind that more power equals more heat, and the best way to make sure that all these components properly operate for their total life is to operate them within the limits. So after all the testing that Rotax did and inspections, it actually told them that they needed a new operating fluid for this engine, and the most important one of all, which is the correct oil. So during all the tests, Rotax found new stresses being put onto the engine, that the Aeroshell Sport Plus 4 was not providing proper protection on its components. So Rotax worked for several years with an oil manufacturer that works for all their other product lines. And this oil was specially formulated and developed for the 916. The oil is available from any of the independent service centers throughout the region. And the oil is now being tested for the 915. As you can see, it's a fully synthetic oil that is good for auto gas and MoGas. So it's very thin. It has a very wide range of density. As you see, it's a 5W50. So it starts out very thin, and then it thicks out quite a bit. So now we know that 160 horsepower is being produced by the engine. We know that it is being properly harnessed, and we know that it can safely be maintained with its newfound power. Now the gearbox must properly transfer all that power to the prop. So the overload clutch has a higher torque value than before. They actually made a new prop shaft. They designed a new prop shaft for this engine. The prop flange itself, it's even thicker than the 915. And as I mentioned before, there is a new needle bearing for the prop shaft that goes on the crankcase itself. As you can see, the prop flange not only is it thicker, but they also change the circle of the bolt pattern. They actually remove the inner circle that before used the small hardware, and they also made the middle circle of the prop flange with the bigger holes as before. You can think of it as like a drive shaft bolts or wheel nuts on a car. How small of a hardware do you really want to put power through? And this engine is making more power, so the new prop shaft and new gearbox improvement also allows for larger, heavier props to be used on the 916. So of course, the heavier, bigger props won't be used in the small bolt pattern. And a small prop, it's really not recommended for this engine in order to be able to withstand the power and properly do it. Now, this information you see will be available in the manuals when they are released, which we're hoping that it's in the next few weeks or so. And only through extensive testing with high quality minded engineers and many hours of proper engine calibration can this really be accomplished. When you see the box that I have on the top there, you can see that the 916 engine was able to make 119 kilowatts at 5,800 RPMs, which is wide open throttle, with 10% less fuel than the 915 on the right. That's 119 kilowatts equals 160 horsepower, and the 915 makes 104.39, which equals 140 horsepower. They were also able to make the same continuous power with 20% less fuel than the 915. With all the new engine components and the trusted history of the 9 Series engine. So one of the reasons Rotax called this the impossible engine is for that reason, because no one really believed that they could make more power with less fuel than the 915 engine. And they were able to do that job, so job done for them. Of course, the 916 is able to maintain the high data transfer rate of all the IS engines. The BUD software is the best way to communicate with engine, and this is really the only way to retrieve and erase any errors, faults, and operational data from the ECU. Learn to use it if you own one of these engines, or make sure that your technician does. The ECU must be interrogated as scheduled and on schedule maintenance. So make sure you're familiar with not only the software, but also the diagnostic tool. Because without this diagnostic tool, you really can't communicate with the engine both ways, back and forth. You can communicate because the display can communicate, but it's only feeding you information. Only with the diagnostic tool can you actually erase and download the information that's inside. So make sure you have a diagnostic tool available. If you have one of these engines, if you don't have one of the tools, make sure that somebody you know does. When they're talking about the BUD hardware, of course, they're talking about the diagnostic tool on the right. ECU is short for electronic or engine control unit. And one of the things you should note is that without the diagnostic tool, the BUD software will not operate. So it won't even turn on unless you have that plugged in. So in reality, the best way to use all of the power from the engine is to have a constant speed propeller, because the only way to achieve 160 horsepower from these engines is at 5,800 RPMs. You got to remember that 5,500 RPMs gives you 137 horsepower. So whether you use a hydraulic or an electric, manual control with a knob or a single lever control, you should be using a propeller that can absorb the load from the engine at its maximum RPM. Anything else, you have to compromise, and compromising, nobody gets what they really want. But the best part of this engine is that you can incorporate the single lever control because it's a CAN operated engine. And RS Flight System is one of those companies that actually is capable of providing not only information for the engine, but also capable of providing prop control. And here you'll see one of the EMUs developed by RS Flight Systems. And because of the limited memory in the Rotax ECU, during the design and phase of the 916 and 915s in the past, and the development of the prototype engines, Rotax required all manufacturers, all OEMs, to have a type of data logging equipment that was capable of storing large data. If in there they wanted to store the complete 1,200 hours of the 915 and whatever amount of hundreds of hours were available from the 916. And the only company that was capable of providing that was RS Flight Systems. Flyrotax.com is the official Rotax website. All the official information is available there. They have all of the manuals, service instructions, and documents. They also have instructional videos that you can view anything they have. RotaxFlyingClub.com is essentially us. What we do is we provide the training, we provide essentially service and provide support to the network. And it shows all of the locations for the service providers for Rotax that are current. There you can find the map that allows you to locate the nearest service provider to you. There's also rotaxowner.com. Here you can sign up for free emails regarding Rotax information. Perhaps it might pertain to you, it might not, but it is free of charge. So I would suggest going there and signing up. Also, there's rsflightsystems.com. They have test equipment. They have the single lever control systems. They have engine displays and many more.